All right, guys, let's get into some new terminology and properties and stuff like that. And let's just think about a little diagram here. And let's see if we can we graph the set of points that are equidistant. So same distance from the focus. Okay, so just imagine there's some point. Okay, this right here. It's just in a random location, and that's going to be called the focal point or the focus. And there's also a line. So this line right here. Okay, it's just a line that goes on forever. Okay, that's not the x-axis necessarily. It's just some line anywhere. Okay, and let's say we want to come up with the set of all points that are equidistant from the focus to the directrix. Okay, so let's kind of think about this. For example, if there happened to be a point right here, okay, that point is 2 units away from the focus. And the way you measure distance to a line is you have to go straight perpendicular. So that purple point is also 2 units away from the directrix. Okay, so that point is one of the points that is equidistant, right, from the focus and the directrix. Another one, imagine if I were to put a point, if I were to put a point right there. Okay, that point, again, from there to there is 4 units. Okay, and the distance from that focus straight down to the line is also 4 units. Okay, so that point would meet the conditions. Okay, I could do the same thing 1, 2, 3, 4 over here. Okay, that point is 4 units away from the green dot and also 4 units away from the red line there. Okay, and what ends up happening is if we were to continue this and list all of the points, if we list every single point that is equidistant, you would end up getting this shape that should look familiar. Okay, and this is just a rough sketch of it, but you end up getting a parabola. Okay, this is the definition of what a parabola is. Okay, it is the set of all points that are equidistant from a fixed point, okay, which we call the focus, okay, or focal point, and a line, which we call the directrix. Okay, and of course the parabola itself has a vertex, all right? It always has a minimum or maximum, depending on which way it opens up, or down, or left or right. We saw it could be an x equals parabola, which would open sideways. Okay, but they're going to have a vertex and a bunch of other points, and any point on that parabola is going to be the same distance to the focus and the directrix. Okay, so just to visualize it, let's say there's a point right up here, right? Okay, if we could measure the distance directly to the focus, whatever that distance is, it would be exactly equal to that distance. Okay, and I may not have drawn this perfectly, but if we were able to, get those distances exactly perfect, then that point would be on the parabola. Okay, so that's the definition. So let's talk about a couple of terms here. This focal length and focal width. So the focal length, okay, first off, the focal length is going to measure the distance, okay, or length, right, from the vertex to the focus. Okay, and again, focus or focal point mean the same thing. So in this case, that distance from there to there, in this example, that distance would be 2, okay, for this specific drawing. Okay, a lot of times we're going to use the letter P. For some reason, the variable P will represent that. Not really sure why they chose P, but we'll just kind of go with it. Okay, that is the focal length. That one we're going to use a lot. The other one, this focal width, we don't really use it much. What it is, though, it's measuring the distance through the focus from here to here, for example. That the length of that segment is kind of like the width of the parabola. But of course, if we go higher, and then the width up here would be longer, and so on. So it has to be going through the focus, and then kind of be cutting through the parabola. So it's just going to be the width of a segment which goes through the focus. Okay, and the focal width is actually the length of that segment. So for this example, what would that be? 1, 2, 3, 4, 5, 6, 7, 8. It would be 8 units. Okay, that would be the focal width for this problem. Now that value, not nearly as important. It's not going to be as meaningful to us. But this focal length here is going to be a big one that we're going to use when we try to find the equation. Okay, so let's look at a couple examples and put this all together. All right, so if we go back to this vertex form of a parabola, okay, there's going to be a couple ways that we can do it. Remember the y equals parabolas with the vertex, of course, at hk. The y equals ones are going to open up if a is positive or down if a is negative. And the x equals 1 open to the right if a is positive and to the left if a is negative. Okay, so what ends up happening, okay, or let me just draw a little bigger picture here. Let's do this one since the previous page had the one opening upward. In this case, of course, you're going to have your vertex here. Okay, that's going to be, the coordinates will be hk, right? That are determined by the vertex form of the equation. Okay, the focal point, or the focus, is always going to be like inside of the parabola. Okay, the parabola always opens towards the focus, and the directrix would be, in this case, like this. Okay, that would be the directrix. Okay, on the parabolas that open sideways, let's just draw them a little bigger here. Okay, again, let's say the vertex is here, right? That's our vertex. The focal point on there, again, the parabola always opens towards the focus. So the focus is always like inside of the parabola. And then the directrix would be whatever that distance was, it would be that same distance, just on the outside of the parabola. Okay, and that distance, that focal length that we talked about, okay, is going to be very closely related to the a value of the parabola's equation. Okay, so let's take a look and see how that is related. Here's another, let me draw one more picture here just to have something to visualize. So as we, I guess we can make it a highlighter. So there's the actual parabola, okay, with a vertex right down here. Okay, the focus again is going to be here. Okay, now it may be closer or maybe farther away from the vertex depending on the equation. Okay, and then the directrix again will be the same distance but down here. Okay, the directrix, right? Okay, now that distance, or the distance from, get a better color here, the distance from the vertex to the focus, from there to there, that distance, which we're calling the focal length, okay, and again, P is going to be the variable we use. Okay, here's an equation for us. One thing that you kind of just need to remember, it's almost easier just to memorize it than trying to derive where it comes from. But P will always equal 1 over 4 times the a value from the equation. Always. Okay, this is just like a always set in stone kind of thing. Okay, and when I say the a value in the equation, remember how the equation would be like a times x minus h squared plus k. So that a value in the equation is always mathematically related to the value of p. Okay, and let me just do one more thing before we start using it. Okay, so if p equals 1 over 4a, right? Again, that's just one, I'm just telling you, just kind of commit that to memory, just use it. We're going to use it. Okay, if p equals 1 over 4a, we could solve that for a, okay, and see what a equals. Because sometimes you may know p, but you won't know a. And sometimes you'll know a, but not p. So you're going to want to have the equation both ways. So again, here's the equation. P equals 1 over 4a, right? Okay, if we were to multiply both sides of that equation by 4a, so multiply this side by 4a, multiply this side by 4a, right? We would then end up with 4 times a times p equals 1. Okay, and picking that up over here, to solve that for a, we could divide both sides by 4p. Okay, getting the 4's and the p's to cancel, and that would give us another version, or another equation that says a equals 1 over 4p. Okay, so we have these two equations, and again, I know your head might be spinning, like, what are all these variables, and what are we doing? Okay, we're going to get to that in just 1 second. But those are the two equations. And notice they're both basically the same. If you need P, it's 1 over 4A, right here. If you need A, it's 1 over 4P. So they're both 1 over 4 times the other one. Okay, and just algebraically, that's just true the way that they are. Okay, so let's use them a little bit. Okay, once we see it in action, I promise it'll clear up a little bit. But just always remember it's 1 over 4 times the variable equals the other variable. Okay? All right, let's take a look. Here we go. All right, here's an example. Can we use the given information to write the equation of a parabola? Okay, and they're giving us the focus is at 5, 7, and the directrix is a line y equals 1, and the graph opens up. Okay, so with these problems, trust me, you're going to want to make a sketch. Okay, it doesn't have to be, you don't have to use graph paper to make it perfect or anything, but you're going to want some sort of just visual of what we know. Okay, so let's take a look at what they gave us. Okay, the focal point is at 5, 7. Okay, so 5, 7. Let's see if we can plot that over at 5, 7, right here. Okay, that's going to be the focal point. Okay, our directrix is the line y equals 1. Okay, y equals 1, of course, is a nice horizontal line. There's the line y equals 1. Okay. And just based on this information, we kind of already know that the graph opens up, right? They did give that to us, but again, if you remember that parabola is always open towards where the focus is, okay, and away from the directrix. I know it's going to have to do something like this, right? Now we'll find exactly where it is in just a second. Okay, one thing we can do though, okay, is think about vertex form. Since it opens up, I know it's a y equals equation. It's going to have some positive a value, x minus h squared, and then plus k. Okay, so we're going to need to find a, and then we need to find h and k. Okay, so let's think about this picture that we have here. If we know where the focus is and we know where the directrix is, the vertex will always be the same distance between those two. Okay, any point on the parabola is going to be equidistant. Remember the definition. So if we figure out that these two are 1, 2, 3, 4, 5, 6 units apart, I know that the vertex would need to be right there. Okay, that's going to be our vertex. It's exactly the same distance. Okay, it's 3 units apart from the focus, right? And 3 units directly down to the directrix. Okay, so we know the vertex. Okay, we know that our vertex is going to be at the point, what is that, 5, 4. Okay, that is the h and the k, right? Vertex form, that's the h and the k. So we know those now. All we need to do is go ahead and find the value of a. Okay, so let's do that. That's where we're going to use this formula. So let's find a. Okay, we know that a always equals 1 over 4p. Okay, and p equals 1 over 4a, right? So in this case, we need to use the equation that's a equals 1 over 4p. Okay, p now is the focal length. It's the distance from the vertex to the focus. In this case, that distance is 3 units. That's the value for p, focal length. So the a value is going to equal 1 over 4 times, in this case, 3, which of course is just 1 over 12. Okay, that's our value for a. Okay, now, right, let's just mark that. That is the value for this a right there. Okay, so now we can put the whole equation together. The final equation, our final answer is y equals, okay, a we just found is 1/12. Vertex form, it's x minus h, so x minus 5, right? Right up here is h and k squared, and then plus 4. That is our parabola. Okay, it would do something like, let's see if I can do that in highlighter. Again, it would do something like that. Okay, and I don't know exactly what it would do without graphing it, but it would do something like that. And we have the equation. Okay, so that's how you use the focal length in order to find the a value. All right, let's do another one here. So this one, they're kind of giving us some information on the graph, and we need to pull some information out of there. Okay, So we see our focus. Okay, let's just get some coordinates there. The focal point there is looking like it is at 4, 3. Okay, right there. This is the vertex of the parabola. Okay. So can we find the equation of the directrix? Okay. So the directrix is always going to be the same distance away from the vertex as the focus is. So in this case, vertex to focus was 2 units. So I'm going to go 2 units the other way, and the directrix is always a line. Okay, it's not a point. It's a line. In this case, it would have to be the line y equals 0. I'm sorry, x equals 0. Sorry about that. X equals 0. It is just the y-axis. Okay. In this example also, that distance from there to there, that focal length that we call p, right, equals 2 for this problem, because we're going to need that in a second. Okay, so anyways, let's answer some questions. The directrix is the line x equals 0. Okay, and we found that again just by knowing it had to be the same distance, just the other direction away from the vertex. Okay, our vertex for this example, the coordinates are, we found that to be 2, 3. Okay, so that's going to get used when we want to do this part here when we get the equation. Okay, let's think about the equation now. Okay, this one, since it's opening to the right, it's going to be an x equals equation. X equals a, and when it's x equals, the y minus k goes in here, and the h goes on the outside. Okay, h is always for horizontal. It's always going with the x. K is going with the y. All right, so let's think about that. We know, here's our h and our k from the vertex. Okay, so I know it's going to be y minus 3 squared plus 2. I just need to, like we did in the last problem now, find this value of a. Okay, and we know to find a, we need to use p. Okay, so let's do that. So I know that a, oops, I don't want to do a highlighter. I know that a always equals 1 over 4 times p. Okay, and in this problem, the value of p, remember that distance from the vertex to the focus, that distance was 2. Okay, so 1 over 4 times 2 is 1 over 8. Okay, that's going to be our value of a. So that makes the equation of this thing, if we put it all together, x equals, it's going to be the a value of 1/8. Okay, look at the vertex now, y minus 3 squared plus 2. Okay, that's going to be our final answer. Now, if you wanted to graph that in your calculator, you would have to solve it for y. It would involve a bunch of steps. I'm not going to go through all those steps. You can graph something like this on Desmos, and it'll show you if you want to just verify it. But that's kind of the process to solve that one. All right, let's do one last example where we kind of have to find the properties if we're given the actual equation. Okay, so let's think about, for example, let's consider y equals 1/4 x plus 2 squared minus 3. Okay, and let's say we want to find the focus and the directrix. Okay, so what we know, okay, and again, I'm always suggesting to do a little sketch on these, right? So if we want to just kind of give ourselves a rough idea of what this thing looks like, based on vertex form, I know it's -2, -3 is our vertex. Okay, and I know the graph opens upward because of the a value is positive. Okay, so it looks something like that, okay? So if we want to find the focus and the directrix, okay, just remember the focus is going to be somewhere above the vertex. We don't know where yet, and the directrix will be somewhere beneath, okay, and it'll be a line like this. Okay, so what we need to do though is find out how far apart is from the vertex to the focus, and we need to find that focal length. Okay, I'm just putting a dot there, but again, I don't know where it is. So we need to find the focal length so we know where to put the focus. And we also will tell us where to put the directrix in. Okay, so the focal length is P, right? We know the formula for P is 1 over 4 times A. Okay, now in this problem, we know the A value is 1/4. Okay, so P is going to equal 1 over, let's get a new color here, like 1 over 4 times the A value, which was 1/4. Okay, and 4 times 1/4 in the denominator is just 1. So our focal length is 1. Okay, so that means, let me zoom this in a little bit. Since our vertex was at -2, 3, that means that the focal point, the focus, I should say, is going to be 1 unit above that. So the focal point will be right here, and the coordinates of the focus will be then, its x is -2, and its y is also -2. Okay, now again, keep in mind, it's not always going to be exactly 1 unit above. That only worked out because of the A value in this situation being 1/4. Okay, and then our final thing, the directrix, is going to be exactly 1 unit below the vertex. So if the vertex had a y value of -3, the directrix, this line here, is going to have an equation of y equals exactly 1 unit below that, so y equals -4. Okay, and again, it's a line, it's not just a point. Okay, so you can use the equation, okay, when we were given the A value this time, right? You can use that here to find the focal length and then use that to find the focus and the directrix. All right.